Last category is combining radicals of different roots. Okay, so it looks kind of weird, right? But it's okay, we can do it. So we're gonna write the fourth root of the third root of j as a single radical using the smallest possible root. So I think for these, it would be easier to first convert it into a fraction, and then we can convert it back into a root. So remember, when you have a fourth root, that is really to the power of 1/4. So I'm going to rewrite this as the third root of j to the power of 1/4. So all I did was taken that outside radical and rewrote it as a fractional exponent. And we're going to do that again, one more time. So now there's a third root, so I'm going to rewrite that radical as a fractional exponent as well. So that would be j to the power of 1/3 to the power of 1/4. Sorry, that's a really ugly 1/4, but it's okay. So I'm going to pause here and see if there are any questions up till this point. So continuing on, we have j to the power of 1/3 to the power of 1/4. So for these, we're actually going to multiply these fractions. So this is j to the power of 1/3 times 1/4. And then since there are fractions that are being multiplied, you can just multiply straight across. So on the top, we have 1 times 1, which gives us 1. On the bottom, we have 3 times 4, which gives us 12. And then now that we have one singular exponential, where it's j to the power of 1/12, instead of this layered stuff over here, now we have one fractional exponent, and now we can convert it back into a radical form. So remember, when you're converting from fractional exponents to radical form, you have your root. This number, the 12, I'm like, how do I point to it? This 12 goes over here, so it's a 12th root. The base, the j, just goes inside. And then it's j to the power of the numerator. So j to the power of 1 inside of a 12th root. So when you're entering in on Delta Math, you don't have to write j to the power of 1. That's just the same thing as j. So you could write j to the power of 1. I don't think they would mark you wrong, but you could just put j there and then put it as a 12th root. So the 12th root of j. Are there any questions for this problem? I'm going to pause the video. Okay, so we're going to go ahead and enter in the 12th root of j. Oh, I forgot how to type the letters for a second. There we go. It's been a long time. So 12th root of j. And we're good. Okay, let's go to the next problem. Let's do this one also. Okay, so this one we have k to the power of 7 multiplied by the third root of k to the power of 11. So let's turn these into their fractional exponent form. So this one is k to the power of 7 over, and don't forget this number, even though you don't see it, it's a 2. Well, I thought I was writing that in red. This is a 2. So it's going to be 7 over 2. And then this one is going to be k to the power of 11 over 3. Because remember, the radical number is just going to end up as your denominator over there. Okay, so we have k to the power of 7 halves multiplied by k to the power of 11 thirds. So for this one, it's a little different from the previous problem, because the previous one you had a radical inside a radical, which means we had to multiply the fractional exponents. This one, they're just being multiplied together. Your exponentials are being multiplied together. So this one, we just have to add our exponents. So 7 halves plus 11 thirds. So we're just adding our two fractions together. So it's kind of like the last category. So since we were adding two fractions together, 7 halves plus 11 thirds, they have different denominators. I can't talk. They have different denominators, so I'm going to show the work up here. So right now the denominators are 2 and 3, but we want them to be something like 6, so that you can add it together. So if I want 6 as our common denominator, I'm going to multiply this first fraction by 3 over 3. Going to multiply that second fraction by 2 over 2, so that they'll both be over 6. Okay, so multiplying out these fractions, 3 times 7 is 21, 3 times 2 is 6. 11 times 2 is 22, 3 times 2 is 6. And then, when you add two fractions with the same denominator, you keep that denominator, so it's still going to be a 6, but then we can just add straight across the top, 21 plus 22, so that's going to give us 43. So then, over here on the bottom, we have k to the power of 7 halves plus 11 thirds. Well, we just found out that that would end up being 43 over 6. Okay, and if this was the last category, we would have been done, except that we want it in radical form. But that's just one more step, and we can totally do this. So we have to put it in a radical, of course. The k goes inside, k to the power of the numerator, so 43, all over 6. So that means 6 is our radical number. So we want the 6th root of k to the power of 43. I'm going to pause the video here and see if you guys have any questions. Okay, so for this one, I just totally forgot to unpause my video, but that's okay. I'll just quickly go over it. So since we have another layered radical, you convert the outside radical, the 5th root, into an exponent of 1/5. So that's what I did over here. And then you do the same thing for the inside radical. Square root of m to the power of 5 became m to the power of 5 over 2. And then you're going to end up having to multiply these fractional exponents straight across. So that's what I did over here. So m to the power of 5 over 2 times 1/5. 5 times 1 is 5. 2 times 5 is 10. So that's how I get 5 over 10 here. And we simplify that to m to the power of 1/2. And then finally converting it back into radical form. So it's the 2nd root of m to the power of 1, but you don't have to write to the power of 1. You could just write m. And so that's what I'm going to do. We're going to have 2nd root of m. And I don't have to write to the power of 1. Okay, and that's it for this video, so I'm going to stop the recording.